Welcome to Desol 4x4 Adventure Hardware, and thank you for tuning into our YouTube channel. Come along for the ride. Learn all there is to know about the inner workings of your shock absorbers and why our monotube external reservoir shock absorber is the best option for your Jimny. To kick off the fun, Lynton is behind the mill and pulling apart a twin tube shock absorber to explain to us exactly how it all works. We follow Lynton into the shock revalving room to learn all there is to know about the EV1 shocks and how they compare in design and performance to our competitors' shock designs.
Okay, with the twin tube design, this particular one, it's a nitrogen charged shock, which means that you've got nitrogen and oil mixed. When we open it up, you'll see how the internals work, but with it being a shock that has nitrogen mixed with the oil, it's generally a low pressure shock. That's why we were able to machine it out on the mill, and you would have heard the underwhelming amount of gas that left the shock. If it was a monotube, the gas pressure would have been far higher, about 160 psi plus. Definitely overheated at some stage. With your twin tube shock, you've got a outer external and then your internal. The external will have some oil mixed with gas pressure, depending what type. Other companies don't use gas, they use foam mat, and the whole point of that is that as a shaft comes in, it's displacing oil from inside the inner tube to the external larger tube, and there also needs somewhere for the shaft to go for that displacement. So the gas compresses a bit more, always creating a pressure in the system, or you've got the foam cell or the foam mat which compresses with the displacement of the shaft. Although this is marketed as a large bore shock, because it's a twin tube you are limited to size, so the outer tube doesn't represent the actual size of the piston doing the work. As you can see here, we've got 170 mils of oil, somewhere in the region of that. We'll compare that to the volume of oil that our shocks take. But it's the inner tube's taking up quite a bit of that oil displacement. What that means is that you've got less oil that can take the heat and dissipate the heat. So the shock is limited to its performance during demanding stages. This controls how the oil flows out of your internal tube into your external tube or your outer tube, and also controls how it flows back in. These shocks obviously are not rebuildable, they'll never be used again. Things on the footer valve, you've got fluid that runs through those holes coming out, and then the flow coming back, so they'll be on your extension, which is your dampening force. This is a little pop-up valve, so it will pop and fluid will flow past there. So unfortunately you guys can't smell what we're smelling, or fortunately. This oil really does not smell good, and it's typical of oil that is heated up to a degree where it starts breaking down. There we go. So this particular shock is a very unusual piston. It's more for your agricultural use. It's got a cast iron wear ring. So the idea is this ring makes contact with the inner sleeve of the shock and stops the piston from actually making contact. And it's got a good coefficient of friction to run up and down.
So the way it's machining, you can see it's cast material where there's cast iron, and then now we're into the retaining plates.
So these shocks are marketed as velocity sensitive valving, and what happens is you've got a hole through here that comes all out to here. That's known as your free bleed. So that generally controls your slow shaft speed movements of the shock. And then inside of here you've got a little plunger and a spring. So what will happen is oil will go through the free bleed hole and out the side, which means it's just bypassing this valving setup here. Then as the shaft speeds increase, this valving setup, the valve itself moves down. The spring is pretty tough, so I can only move it a limited amount of space. And that opens up these ports here. So the further this goes down, the more flow gets through these ports. So as the pressure increases, this plate will compress the spring, move down, opening up this gap here, which gives you access to that port. That port then will bypass this valve and run straight through back into the shock. So that'll be during your high-speed shaft movements. So here's the port that'll be coming through, so we'll be bypassing through there, and there's 4 ports around. So despite our tube's measuring 50.5, where this particular shock tube is measuring 50.8, so technically it seems to be a bigger shock, but the actual working inners is far different. Internal tube of this particular shock is 36.8, so only about, that's 35 piston diameter compared to our 44 piston diameter. So there's a large difference in the piston sizing and makeup. It's a very different shock, and you'll get very different performance from it. So from these pistons, with it being reliant on the spring and this particular setup, springs on the footer valve, springs on the compression and the rebound, it's very difficult to tune these. You're limited to the spring tensions, which also means that your repeatability from one shock to the next is going to be very different. It's going to vary quite drastically. So what we're doing here today is we've got Brad's vehicle here. He's got one of our earlier valving setups when we're just testing and playing around with the different setups and trying to achieve different feels on the vehicle. With Brad's, it was a super plush setup. But it does mean that as you load it, you start losing that the control and stability. So we always trying to find a happy medium where we can valve between that. So we've got the plush setup as well as taking the big jumps and still handling the high-speed freeway application. Okay, how these work? We've got the front shocks. We've got the compression and the rebound valving setup here. This is a very different setup to what we previously had, but as you can see, as we replace the shims with different size shims and different thickness shims, we're going to get different results, and we can adjust the compression and rebound throughout the speeds by using different shim setups. A thicker shim is going to create a hard evolving, and then as the shim gets large in diameter, it's going to soften up. So despite the shock having such a large appearance, the oil volume here is only sitting around 200 mils. That's due to the having a twin tube, internal tube inside of the larger outer tube. The outer tubes can obviously contain a mixture of oil and gas. Overview of our bearing block. This is one of our older models, but if we compare the two, you've got your very thin DU bush in there. You can see just how thin that DU bush is. Let's get a measurement, let's be scientific. 11 mils, probably about 10. So this DU bush is about 10 to 11 mils thick. So as you can imagine, it's got very little surface area on the shaft, which does give it, which does affect its lifespan, and also the ability to cock over. It's not a drastic issue with the shock absorbers, because you also are located both on this bush on the shaft and here, creating a better control of the shaft in the bush. This acts as a high pressure seal as well as a wiper seal, so it's all in one component. With ours, we're using a 16 mil DU bush with an X-ring as well as a high compression, a high pressure seal, and then a high pressure wiper seal. So this is a U-cup seal, so you can see that's got the ability to retain the pressure without losing oil. And then on the other side of the face is the wiper seal, ensuring that the shaft is clean at all times. So when it is compressed back into the shock, the shaft will be wiped clean by the wiper seal. So it's a high pressure U-cup seal. What happens is, as the pressure builds up, these two faces push apart, creating a tighter seal on both the shaft and the bearing. So that ensures that as the pressures vary throughout the shock's movement, you're still going to retain your oil in the right place. So this is what makes the shocks serviceable and rebuildable, is that each one of these components can be replaced at any stage of your shock's life, ensuring that you'll have a good quality shock that's retaining the oil and the gas. With Brad shocks, the shocks are relatively new, so we're not doing major service on it. While we're at it though, we're just going to do what we do with a minor service, which would be to replace the O-rings. This is just the sealing O-rings to retain your oil, and also just to show you how easy it is. And that part is done. We're going to show you building the shocks on one, building the pistons on one. From there's a few more features I'd like to show you that's different to what we've just seen. Okay, on the building aspect of the shock, we always use orange and silver. Silver is always rear, orange is always front. This is just so we don't get them mixed up. And then we've set this up so the top two are the rear, bottom two are the front. This is our rear shaft compared to our front shaft. You can see the length. The rear shocks are set at an angle. That angle allows it to have a longer shock length, and then obviously we've got to valve the shock accordingly. You can see how much shorter the shock is, and then I think the shaft is 14 if I'm not mistaken. Yeah, 14, and then ours is 16. So we're using a heavier duty shaft as well. So let's build one of these. We'll show you how quick and easy it is, especially once MS has laid out everything for us to make our lives easy. The bearing block, so now we're just going to put one of the rears together. These are just spacers. The reason why we have these spacers is it allows us to go for a greater shim variation, and we can, for the bigger vehicles, we can start putting bigger shim sticks to allow for the better valving. So basically each one of these shims acts like the spring that you saw on the previous shock, except we've got great adjustability. We can adjust the thickness of these by 0.5 millimeter, and we can adjust the diameter to 1 millimeter. We could go smaller than that, but it's not really feasible. On the piston itself, we spoke about the free bleed. We use these little ports that are covered by grub screws. Those are our free bleed holes, so we can add them or remove them to get our variable or varying slow speed shaft movement. Thereafter, we've got our ports here. These bigger ports here are our compression ports, and then these smaller 3 ports here are our rebound ports. They're smaller and they're closer together. The reason why is that we're trying to create more pressure on your rebound. It's overcoming the coils as well as the velocity of the vehicle moving up. As the piston is compressing, these are blocked off. These ports will be accessed, which will then create this piston or this shim to lift up and down, allowing the oil to flow through. And then vice versa, as on this side, these 3 ports are open, which is giving oil flow through to these ports, which, as you can see, is going to be covered by the rebound shim. For this particular build, our fronts are all going to be closed, like that previous piston you saw, and then we're going to be opening 1 port for our rebound on this particular build. This we're going to talk about now, but this is our top out washer. So what it does when the shafts put all together. Okay, one of the key features in the shock is we've got this recess where you can see it better in this design here. So the reason for that recess is when the shock fully extends, you end up with top out. So basically, if you had to hit a jump where the vehicle becomes airborne, the shock's going to come flying back and make quite a drastic stop against the piston. So this obviously is going to be damaging all the vital components here. With ours, as it comes down, the top out washer starts entering into the bearing block, and as it enters into the bearing block, it's going to create the hydraulic lock. We've got a 1 more hole here to allow the oil to bleed out, and then on top of it, it's inserted into the tube. So you've got very limited flow through here, creating a hydraulic top out bump stop. There are different manufacturers have various ways of doing it. Some manufacturers are using a 3mm rubber cushioning. For us, we prefer this way. Got a lot more control. Allows time with more extension when flexing out, where if you had hard rubber there, the hard rubber will be a fixed stop, where this can slowly force the oil out and then get your top out position. So with the monotube design, and with it being a closed system where the gas is separated and compressed, it allows the shock to be run in either orientation, so you're not limited with that. With the twin tube design, with that little footer valve, and the fact that there's gas and oil mixed, when you move that shock upside down, so this would be considered the upside down position with your footer valve at the top, you end up aerating the oil that's in the tube, which will stop the shock from functioning correctly. So there's another benefit with these shocks. We often get asked why choose our shock over the competitors. First of all, it's a high performance shock. It's in a different league completely. And what you've got to ask yourself is, once your warranty is over, do you want a shock that you can rebuild, repair, and revalve to your likings, or do you want a shock that you're going to have to throw away and start again? The other aspect is, as you all know, with these Jimnys, we start off with an idea in our head, and we're not going to drive our vehicles hard off-road. We're not going to load our vehicles heavy. And as you start enjoying the Jimny and you see the capabilities, you start driving the vehicle harder, you start loading the vehicle more. With these particular shocks, once you've bought them and you decide that you're going to put a draw system in and you want to start loading the heavier weights in the vehicle, with our product you can bring the shock back to us. We will then revolve it for you to suit the loads that your vehicle is carrying, and you're not having to purchase a shock all over again, the entire suspension system all over again. With the standard Jimny, we get a lot of customers complaining about the vehicle's on-road performance, especially speeds about 120 with loads. You start getting that wallowing jelly effect. And we've got a lot of customers that are scared to go to the 50mm lift because they think raising the vehicle is going to make that worse. With the shocks being valved correctly and tuned for your vehicle and tuned for the spring rates, even with the 50mm lift, the vehicle's handling is far superior than the stock. It is absolutely, it's chalk and cheese, you can't compare the two. We've got a lot of customers that have fitted our competitors' suspension kits. They're still battling with the instability of the vehicle on the freeway at freeway speeds, especially when loaded, and they're coming and asking about wheel spaces, etc. Putting a wheel spacer on for instability is like putting a band-aid on a broken leg. The problem does come down to the shock and the shock tuning, and it being rated for your particular vehicle and the weights. A wheel spacer is going to enhance your performance of the vehicle, but that your shocks need to be there. Your shocks need to be in place first. You need to have the right valve shocks and have a stable ride before the wheel spacer is going to really give you any real-world benefits. We often get asked the question of where we're importing our shocks from, where we're importing our suspension from. I hope this video assists to clear things up. All of our components are manufactured here in this factory, which gives us complete control over the product, the manufacturing process, and the quality, as well as gives us the ability to upgrade the system as we progress down this road. And to add to all of this, our shock is a modular system. You can upgrade your shocks as our technology advances and as we improve the shock.
Compared to the twin tube of 200 mils of oil, we are using 450 mils of oil in our setup, over double the volume.
Our coils have been designed in-house and we have an external company manufacturing them. We designed it to our specifications for the needs and purposes that we require on our vehicles. So the main reason for going for a dual rate coil is that these Jimnys are very sensitive when it comes to weight. So we add a little bit of weight and the suspension becomes very soft. And then we upgrade the suspension for the added weight, and when we're not carrying that weight load, it becomes very hard. So the point of the dual coil here is we've got the first portion here, these 4 coils which are closer together than the rest. These become our softer coils. So this is for when it's unloaded. They'll take up majority of the movement, allowing it to be a softer and plusher ride. As they get more and more compressed, they start, what you get is spring bind, which means that there's no more movement in them, and the rest of the coil then will take over for your heavier loads. There's 2 key features. The upside is that your ride's going to be far smoother and softer throughout your load range. The downside is that if you do put on a heavier load as a daily, your 50mm lift will be slightly lower to a 40mm lift, or depending on the weight that you are deciding to load onto the vehicle. What we've done to counter that is that our coils actually sit slightly higher than a 50mm lift. That's why I see that they do have a rating, and it should take in a region of 200 to 250 kilos of weight, additional weight on that vehicle to bring it back down to the 50mm height. So this allows you to add on your general products like your bumpers, long-range fuel tank, underbody protection, roof rack, and still maintain a 50mm lift ride height. Yeah, misconception is that only bottom coils are active until they bind, but that's not true. The entire, both the soft and heavy duty portion of the coil will be active, and then only once the bottom portion is completely spring bound will the heavy duty part take full control. The benefit of this is that as the spring load increases, it's going to have a nice transition between your soft, medium and harder, or light, medium and heavier carrying capacity. When comparing that to a normal single rate coil, is that as you load that coil, your newtons per millimeter will not change. So 100 newtons will get you down a certain amount, and 200 newtons will get you down double that. Okay, last but not least on our suspension components, we've got our heavy duty radial arms, 10 more plates in the center with 5 more plates creating R-beam effect. We do have lightning holes cut into it to reduce the weight, and then we've got our disassemble 0 degree bushes in here. So these bushes have been designed in-house. The injection mold also designed and manufactured in-house, and we've got an external company running them for us. We do set these bushes up in a certain orientation. The reason being is that as your arms are moving, your bushes are compressing. So we've orientated this bush in this direction to allow a bit more up and down movement, and then we orientated this bush in the vertical position, and that helps limit axle warp when you're under braking or acceleration. So the benefit of these bushes, they're not over molded. They actually can rotate freely within the bush itself. So when they're clamped on the radial cups, it gives it a free movement coming up and down. What that does eliminate is, or assist to eliminate, is caster bind. It does also assist to give more flex, because you're not having this bush that's getting wound up as it gets to its top position and then releases as it lowers down. So this particular arm here, this is an upgraded arm. We did this arm specifically for the Gen 4s if you want to do a 31-inch tires. This pushes the diff out another 8 to 12 mils. That allows your tire to turn without catching the inside of your wheel well. With that 4.5 degree caster, it really does give you a much better drive. So we're sitting at 4.5 degrees caster, between 4 and 4.5 degrees caster on a 50 mil lift. That will allow us to go all the way up to 100 mil lift and still be within the Suzuki Jimny specifications of caster. In order to achieve that, we have had to cut out here. That is to allow your trailing arm to run past you without getting bound. In conjunction with this, we also do OEM replacement arm, which is still a heavy duty arm, utilizing our bushes. We can go for your straight pin bush, which is going to give you your 0 caster, which would mean it's going to keep it in the OEM specification, or we can put the caster, the 2 degree caster correction bushes in for the 50 mil lift. The reason why we've done this is, especially with the 5 doors, we've noticed a lot of vehicles getting bent radial arms, so maybe something for you to check. These are made out of injection molded TPU. The benefit of this is that it is extremely hard wearing product, and it's also chemical resistant. The way we've designed these bushes is specific to our application. We have got cutouts to allow it to compress and cock easily with limited resistance. The point of this is to try and get the most amount of flex out of your bush. As your pin is moved off of center, you start losing flex. So if you think about a solid polyurethane pour mold bush, you've got very limited area to compress at the top with a lot of area at the bottom. This starts limiting your ability to flex, and you start encountering something called caster bind. You will still get caster bind with this, but you'll have a lot more movement before getting to that point. On top of that, our bush actually has a solid inner core in between these cutouts, which you can't see, and that will allow the bush to stay stable throughout its life, even if the end starts wearing and deforming. It won't affect the bush's performance at all. It will still function 100% to how it's supposed to. We've seen a lot of iterations of cross members and drop down cross member kits and all the rest. We've opted to keep our cross member as close to OEM as possible. The reason why is that as you're raising your vehicle and you're dropping down your cross member, there's two things that's happened. Your cross member now is becoming the limiting factor with your ground clearance, apart from the diffs. But the other aspect is that you've got your mounting brackets up here. Your shocks, your cross member was on these mounting brackets, now you've got a drop down kit. Your cross member is more exposed to rocks than other obstructions. So we've opted to keep ours nice and snug like the OEM one is. We've got a cutout to allow the front prop shaft to drop lower down and go in between. And as well as that, we've reduced the thickness of it to give it a bit more clearance. We have then also strengthened it up with internal structure supports in this entire system.
Now that you know all there is to know about your EV1 shocks and all the other ancillary components that we've looked at to improve, to make sure that your Jimny has the best drive when you have the correct valving, the correct setup for your Jimny, know that no matter what obstacle you're tackling or the longest journey you're facing, you can have full and complete confidence behind your suspension components. Drop any other questions you may have below in the comment section or get in touch. To transform your rig today, head over to www.desol.co.za and place your order with delivery to your door. Keep your eyes peeled for more educational videos coming soon. Thank you so much for watching this far. Please remember to click like and subscribe. We appreciate all the support you guys give us. Until next time, make time and go live your adventure.